Hi, welcome to Matcom. In this particular video, we will be discussing about one important aspect from NCERT Chemistry Class Plus 2 in the chapter Organic Chemistry, Alcohol, Phenols and Ether. This particular topic was associated with preparation of ether. In the textbook, there is a statement: the dehydration of secondary and tertiary alcohol favors the formation of alkene rather than ether. But there is no further explanations are given. But this particular kind of questions can be asked in case study. These kind of things can be asked in assertions and reasoning. So we need to understand the chemistry behind or mechanism behind this particular thing. In our series, we have discussed a lot of aspects in chemistry, mathematics, and we have discussed in relating to quantitative aptitude. You can check out in the playlist. And if you're interested, please share with your friends. Okay, so we will start the question. The dehydration of secondary and tertiary alcohol favors the formation of alkene rather than ether. So, whenever you're considering the formation of alkene or ether from an alcohol, it formed by the dehydration process. If you're considering an alcohol like CH3, CH2, OH, it's methanol. In presence of any protic acid, such as in presence of sulfuric acid or H3PO4, that is phosphoric acid, if it is at low temperature, usually at 413 Kelvin, and if the same reacting mixture is placed at 443 Kelvin, the product would be different. The first case, you will be getting an ether, CH3, CH2, O, CH2, CH3. The second case, you will be getting CH2 double bond CH2. That means here you can understand it undergoes elimination reaction. By the elimination of water, there is an alkene has been formed. Here the substitution reaction happens. As a result of substitution reaction, we got ether. If you want to know why it happens so, we need to understand the mechanism behind both the processes. So here the catch of the question is, why the secondary and the tertiary alcohols are not favoring the formation of ether rather than it is forming alkene. So if you're considering any ether formation reaction, we are taking simple alcohol, let it be methanol. Sorry, methanol or ethanol you can take. So since we given reaction in ethanol, we will take ethanol itself. CH3, CH2, OH. The reaction medium contains proton, so H plus is there. Oxygen is having lone pair of electron. So using this lone pair of electron, oxygen can abstract this particular proton to become CH3, CH2, OH, H plus. That means we will be getting a species like CH3, CH2, OH2 plus. We know that oxygen is highly electronegative. So the positive charge on electronegative oxygen atom brings it highly unstable. Also, water is a better leaving. Water is a better leaving group. That means water have a tendency to leave fast. Okay. So what we can happen? This particular shared pair of electron will have a tendency to donate or pushed to the oxygen, such that this particular carbon will become a deficient electron, or the carbon can act as an electrophilic center. Rather, it will act as electrophilic center, mean it will be deficient in electron. So in the next step, what we can happen now, another molecule of alcohol. In that particular case also, oxygen will be having lone pair of electron. We are having with CH3, CH2, OH, H positive charge. This is acting as an electrophilic center. Since oxygen is having lone pair of electron, oxygen act as a nucleophile, such that this using this lone pair of electron, oxygen can come and attack this particular carbon. What kind of attack? This is a nucleophilic attack. Nucleophilic attack. As a result of nucleophilic attack, this particular bond can get cleaved to the oxygen, such that water molecules will be cleaved and you will be getting CH3, CH2, OH, CH2, CH3. But we can understand that since oxygen has used its lone pair of electron, in order for the bond formation with the CH2, CH3, oxygen will get a positive charge. We know that oxygen with a positive charge is a highly unstable system. So what will happen? This hydrogen will donate its electron pair, donate the bond pair to the oxygen, such that it will cleave as a H plus ion. such that you will get CH3, CH2, O, CH2, CH3. Understood? Fine. So this is the case. Then you can look in for, if you're considering a secondary or tertiary alcohol. If you're taking a tertiary alcohol, it will be CH3, C, CH3, CH3, OH. This is a tertiary butyl alcohol, correct? So in the first step, there is a proton is there. This proton can be abstracted by using the lone pair of oxygen such that you will be getting CH3, C, CH3, CH3, OH, H, positive charge. The same way we are having with CH3, C, CH3, CH3, OH, H. We know that oxygen is highly electronegative. So this particular system is unstable, that there will be a huge tendency of shifting this particular electron pair towards the water, towards the oxygen. So if we are having another tertiary alcohol, this particular tertiary alcohol, by using the lone pair of electron, the oxygen will act as a nucleophile. It will go for a nucleophilic attack to this particular electrophilic carbon. But see, this is a bulky molecule. This particular electrophilic carbon is highly steric hindered. See, this particular carbon, if you consider this particular carbon, this carbon is highly steric hindered. Why? It is highly steric hindered because of the reason that it is surrounded by 3 bulky alkyl groups. 3 bulky alkyl groups. So this particular nucleophilic attack is not favorable. That means it is a less favorable reaction. That even if it is a secondary alcohol also, the same kind of steric hindrance will be there. That is why the secondary and tertiary alcohols are not favoring, secondary and tertiary alcohol are not favoring nucleophilic substitution reaction by SN2 mechanism. Why? Both the reactant species are existing in the rate determining step. So it is not favoring SN2 because this is a nucleophilic attack is happening. Both the reactant species are there. So it is a substitution because this particular species is substituting this particular OH molecule. That is a substitution. It is nucleophilic because the nucleophile is coming and attacking. So it is a nucleophilic substitution. Bimolecular. Both the reactant species are existing over there. Fine. Then it is not favored. In the same case, it will be happening for the secondary alcohol. So here there is a thing you need to understand. This particular reaction favors SN1 mechanism, but that since I have prepared the video for an NCERT chemistry class +2 perspective, so it will favor SN1 mechanism and it will undergo nucleophilic substitution. But it is not expected for as per our syllabus. So I am not explaining it. But for the higher classes of chemistry, I will explain you in another video. Okay. For this particular perspective, I am not explaining. So if you're taking another case, if you're taking a tertiary alcohol, CH3, CH2, CH2, assume that it is undergoing dehydration of alcohol to form alkene means the mechanism will be the first step will be same and you will be getting CH3 abstraction of proton such that. So this should be CH3, valency should be mandate. So it is going to be OH2 plus. We know that water is a better leaving group. So if it is cleaved, the cleavage of this particular water molecule will form a carbocation, that is CH3, C, CH3, CH3 plus. That means a tertiary carbocation is generated. If a tertiary carbocation is generated, we know that the tertiary carbocation is more stable than secondary carbocation is more stable than primary. Why? Because if there is a charge in a species, means that system is comparatively less stable. So if you are able to minimize this charge density, the stability can be increased. When you are considering these CH3 groups, these CH3 groups belongs to alkyl groups. Alkyl groups are electron releasing group. ERG means electron releasing group. They show positive inductive effect or plus I effect. What is mean by that? they have the tendency to donate the electron pair. So whenever the CH3 is donating the electron pair to this particular carbon, what can happen? The positive charge density around the carbocation decreases, stability increases. Clear? So this carbocation formation is favored. Why? Because due to the stability of tertiary greater than secondary greater than primary. The last step, what we can happen? This CH3, CH2, CH2H, CH3, a carbocation is there. This bond will get shifted such that an H plus ion will be cleaved. So you will be getting CH3, C double bond CH2, CH3. An alkyl will be formed. Why the alkene formation is favored? During the mechanism of alkene formation, there is a formation of carbocation. We know that secondary and tertiary carbocations are more stable. That is why, due to the stability of secondary and tertiary carbocation, they will favor this particular dehydration mechanism, acid catalyzed dehydration mechanism, to form an alkene rather than forming bimolecular dehydration reaction to form an ether. Because ether is formed by substitution reaction, that is also a bimolecular dehydration reaction. Because two molecules are involved, that is why it is called a bimolecular dehydration reaction. But when you consider this particular case, there is only one molecule is involved, correct? That is a unimolecular dehydration reaction in order to form alkene. They can reframe the question in this way also. Why bimolecular dehydration reaction yields ether, unimolecular dehydration reaction yields alkene? What is the difference? When we are able to explain by using the mechanism, it would be very simple cup of tea. Hope the explanation is very clear. If you are facing any doubt regarding the explanation, do let me know in the comment section. As well as if you want further clarification related to any chemistry, mathematics or physics topics, do let me know over there. As a token of gratitude, please like to this particular video. Please subscribe our channel. As well as there are people, those who are interested to learn these kind of things, as well as quantitative aptitude. Different playlists are available in our channel. You can check it over there. Kindly share with the people. Keep watching, keep learning. Thanks for watching. Bye.